So yeah, thanks again everyone for coming, and it's great to see such a good turnout. I think we're always nervous on how many people are going to just show up at the end, and it's great to see the room packed. And today I want to present the work that our program has done with small hive beetle in the Essex quarantine zone. And I think this is a good example of kind of how things can fall off to the side. Something that was so big and so highly talked about very recently kind of quickly goes away once another topic comes up. You know, more like all the things with pesticides and corn seeding. And we've kind of almost forgotten about small hive beetle. It seems like that used to be all that anyone ever wanted to talk about. But we have done a lot of work in the quarantine zone to look at small hive beetle and see how it's developing in our environment and developing best management practices to go along with it. And I know you guys have seen some of this before, but we actually are more or less finishing up that project with the funding that we had. It's always going to be ongoing because no pest is ever, done and dealt with. But we have had really good results with the work that we've done to come up with some good recommendations. So I want to go through that with you today to kind of wrap that topic up. Not that it won't be presented again in the future. And of course, any local associations that are interested in us giving that presentation, we come and speak to you there too. But I didn't want it to just kind of disappear with all the other things that we're talking about now. We've submitted our final reports into OMAFRA, the Ministry of Agriculture, with the funds that they gave us. And we'll have an article coming out in the OBJ shortly too. One of our students, Sarah DeAndrea, she was a summer student this year, did a project with the university, kind of worked it into one of her courses. So she did a really good paper on this, so we want to get that into the OBJ as well. So I have to turn this on still. Yep. Okay, so like I said, some of this is, I know many of you might not have even seen this presentation because I know we've given it a couple of meetings before. Some of it's repetitive, but some of it's new information. But if you haven't seen it, then here's your chance to kind of get the long version. So the first year we were able actually to start working on this was in the spring of 2011. And that was the winter that we still had questions whether small hive beetle could even survive in our environment. Speaking with the folks across the border, they told us that we weren't even going to have to worry about it, that it wouldn't make it over winter at all, and it would just kind of go away. But the first season we had it, we found out that it did fine over winter. The winter of 2010-11 was actually a fairly real winter, not like last winter. So it was a good test to see if that would happen or not. So we knew we had something to deal with. We found small hive beetle on combs running around with the bees. They're often found in dead-outs, on mite wipes if people are using formic acid for spring treatments. The fibers in those pads, they really like to get in there and hide. Tarp inner covers seem to be a good place for them to get woven in with all those little fibers and hide in there. So there's lots of places for small hive beetle kind of overwintering in colonies and be ready to reproduce the next year. So there's just a picture of one of our friends down in Essex County. Okay, so this is a video. So I like to show this one. So here's the beetle here running around. So it was a good example of here's the bee tucked down into the cell there, but they always kind of the beetle just comes out. They have this interchange of, they believe is a pheromone, where at first they attack, so there's another bee attacking it, but then the bee just kind of gives up. And it's a good example of how the beetles are kind of able to coexist inside the colony with the bees on comb and keep on going. So this is a beer coat frame, and in a second you're actually going to see the beetle tuck down into here. So I've even lost it, but it is tucked down in there right now. So even some of the equipment, so we talk about tarp inner covers, these pier goat frames with the little spaces around the edges, all those things kind of play into, small hive beetle and the places they're able to hide, and maybe even some equipment choices you can make if you're worried about small hive beetle. A lot of the new plastic frames don't have those spaces in there now, depending on the type that you buy, and or wooden frames aren't so much of an issue. So this is another one, pollen patties. This is another thing we observed. If you're putting pollen on this spring, they love pollen patties. So you can see the little larva in here. So when you get into best management practices, this is one thing we really like people to realize is if you're putting on pollen patties and you have small hive beetle, if the colony isn't strong enough to take the patties down, eat them all up, then that's a great place for the beetle to start reproducing. When I get into the life cycles that we are able to repeat 2 years in a row, this is exactly the time of year when the beetles are going to lay a lot of eggs and start reproducing. So if they're not strong enough to take it all down, you either have to really moderate the amount of pollen you're putting on for the colony strength, or go back and get those patties off that they're not consuming, because they're just thick enough that they can lay a lot, consume it, and just kind of hide in the patty itself and reproduce. Okay. We did see some kill over winter, so there is a benefit of winter. It does have some kill effect. So we don't really know how much that is, but that always is going to come into the kind of the final conclusions that we've come to in a lot of this project, is that you don't need, even if they killed 90% of the beetles, it all comes down to colony health and their ability to stop beetles from laying. You don't need a whole lot of beetles to survive in order to keep reproducing. So even if there was we're able to measure a large amount of winter kill somehow, if they're still there this spring, they just need a few to keep on going. You do get some winter kill, but it's probably not significant in actually controlling small hive beetle. So with some of those things we saw in the spring, it really highlights your best management practice in the spring, cleaning out dead outs, really weak colonies. If they're not going to survive, get rid of them right away. Just good hygiene in your bee yards in the spring will eliminate places for small hive beetle to reproduce. So just having really clean yards. So this is something we were able to see when we were in a yard with Tom. And often people are barrel feeding in the spring, and this was a barrel of leftover honey that was left in the yard. And this is, Tom, you might not hear him say it, this is his small hive beetle breeding program. He's joking about there. But this was really good to see, because a lot of people do this. You put feed in you barrel feed in the spring, and you leave the barrels in the yard till you get around to cleaning it up again. And then, but in this case, if you came back too late, there's a huge amount of larvae that was able to reproduce in that barrel. And I think Tom, he's had ones with, that was, like I said, leftover honey, but he's also feeds sugar syrup. And there was a lot more in that actually leftover honey that was fed than the syrup. And so it's partly related to the fact that it's honey and probably has some pollen in there to attract them. Excuse me. But it does highlight that, again, that spring hygiene is really important. And something like that you might just kind of forget about and not even think that, oh yeah, I should deal with that. It can actually give a really great location for small hive beetle to reproduce. Okay. So that was some of our spring observations. The next thing that we did 2 years in a row that we actually had some really good results with, and this comes to seeing how small hive beetle reproduces in northern climates. We're able to use this trap that we like to call the Peter Thiel trap, because he was the researcher that he did some work with this trap. Basically, the idea here is that when small hive beetle, when they're in the colony, they lay eggs, produce larvae. At a certain stage in that cycle, the larva comes out of the entrance, goes down into the soil to pupate, and comes back out as an adult. So how do they know to go out the entrance? And there's an effect there where they're attracted to light to come out of the entrance. So he created these traps in order to show that that the larva was attracted to the light to come out of the entrance. Then they go down in this trap, and you could catch them down in the bottom here. So we use this trap in yards to actually, the idea here is that you could actually measure small hive beetle reproduction rates by catching how much larva comes out of the entrance. So you could use that if you're using a treatment against it, small hive beetle. You could treat them and then check to see how much larva came out to see if that treatment worked. A lot of different applications. But we really just wanted to see, we did use this for some small hive beetle traps, but we also want to see just how small hive beetle was reproducing in our environment. And we also measured this up against the strength of colonies, see if there's more small hive beetle reproduction in strong, weak colonies. Varroa infestations, to see if Varroa, if they weaken a colony enough, if that allowed small hive beetle at a certain level to reproduce more, and other traps. So 2 years we did this, because the first year we had some really kind of surprising results. We expected from a lot of the literature that small hive beetle would just kind of reproduce steadily all year, more or less. But we actually had a really defined cycle. So this was the 2011, where we started trapping at the start of May, and we caught a few, and then we caught a few more the next week, and then we saw this peak around the start of June, and thought, oh wow, they're really reproducing now. And then all of a sudden it just kind of trickled off to nothing. It's like, oh, that's kind of weird. Is it just because the colonies are getting strong, or what's going on? But there was definitely this cycle right here, and it didn't seem to, there was no relation between strong or weak colonies. All colonies kind of had this cycle, and this was within 3 different yards at the same time. And then we had this other cycle right at the end of the year in September. And I'll talk about why there's this huge kind of peak in those ones. But when we did that the second year, and I know these lines might seem kind of a little bit all over the place in trying to match in the graph, but we actually did see that same cycle, larva reproduction, from the start of May until about the start to mid-June, and then just drop off to nothing again. So there seems to be this seasonal cycle of larva production right at the start, and then kind of trickles off here. But then in September again, we had this peak. Both those peaks at the end of the year were in compromised colonies, ones that were laying workers. They had specifically a queen issue, and were pretty much on the downward slope. But no matter what, the peaks always happened at that time of year. It was regardless of colony strength, high varroa, any other factor. They always seem to peak at that time of year. And when you work this into integrated pest management, that's really important, because then you can time treatments, when you should be monitoring, when you should be doing certain things. And we didn't actually have that knowledge before. We just kind of thought this would be going on all year long. So you can make better economical decisions on, buying treatments and all of that, if you know when you should treat for larvae, or when you should treat for reinfestation of adults, which I'll talk about shortly. So that was interesting. We were actually able to repeat that 2 years in a row. So this is just kind of a summary of that, that we were able to see that cycle. So you can see here, this is a larva trapped in the bottom in one of those trays. The first year when we did this, there was a lot of rain, and Tom I think Roger's just around. They just loved us because they come in and their yards smell like French fries, and the raccoons have been digging in front of their colonies, and I think they were pretty happy with us that year. I should mention they have been great to work with and patient with us, working with their colonies and donating that to us, because it was kind of messy, these traps, especially when it rains, because you put oil in the bottom of these traps. It rains, and then with a lot of rain, it actually flushes that oil out and gets in the soil, and that becomes a pest issue, right? So that was kind of gross. We had really soft skin with all that oil, but we went through a lot of paper towels in this trial. So like I said, we weighed colonies. This is part of looking at colony strength, their food reserves, all their disease profile. And it seemed like really, like in the spring, because generally colonies come out fairly, they're at their weakest point in their season. All of them are reproducing some larvae. We weren't able actually to show within the colony strengths that we looked at any difference in colony production or in larva production in any of the colonies. Just in general, they're all producing some larvae. Later in the year, that changes as they get a lot stronger. But just the fact that they come out of spring at their weaker state, they seem to produce a lot more larvae. Last year, when colonies came out a lot stronger, there was a little more variation because we had such a good overwintering that they were all producing a little bit, but you could definitely see it was reduced in the amount of larvae produced last year in the spring compared to the year before. So that seasonal difference could have an effect on how much small hive beetle we actually see yearly, just how strong they come out of wintertime and how much larvae they're able to produce at that time of year. That's a fairly long-term study to really look at that. Excuse me. Other thing, a lot of this was dispelling some myths, maybe around small hive beetle and where they can reproduce and where they can't and all that kind of thing. And the first year we did this was completely flooded the yards, and we thought this was going to be a great thing for us and for small hive beetle because they usually like sandy. This is kind of like clay soil. We thought if it's this wet, there's no way small hive beetle can reproduce in that. And this is actually what we would see. We'd see the larvae kind of floating in the water and kind of even swollen from that much water. And they almost look dead. But if you fish them out, and this is my wife, this is Raquel. She was really good. She really wanted to know what was going on. We get in yards, we just want to get our job done, but she was, no, we got to look. So she got in there with her hive tools and her rubber boots and started digging it up and got down the soil and pulled larvae out, and they were alive and doing well. And this was completely saturated soil. So it didn't really seem to bother them that much, the flooded soil at all. And we've heard that comments now from other environments where small hive beetle is, like Hawaii, where it's there's a lot of rock and there's not much soil for them to reproduce in. Either just a little bit of residue in a little crevice, they can reproduce in that. They have their ideal conditions, but if it's not ideal, that really it might slow them down, but they can still take off. So something that we weren't expecting to see as well with these traps that we were using, we thought we were just going to see larva reproduction and monitor that. But we also ended up realizing these traps worked well to capture small hive beetle coming back into the colony. And we're not exactly sure the engineering of how that works. It seems like they came to the entrance and they hide down inside of the trap before going in. And 2 years in a row, we were able to show, all of a sudden they start showing up. We get this peak in small hive beetles, adults, and then this drop off. And both of that happened in relation to the larva reproduction, like what we know about the cycle of them going into the ground, pupating, coming out as adults. It matched this peak of larva production here into where they would emerge as adults and reinfest. So about the middle of July, we started seeing that, and then it would peak around late to start of August, and then drop off about mid-August. By then, kind of all the adults had moved in, and we wouldn't see more coming in. So that's the reinfestation state, and this is the second year that we were able to match that. And all these, this is actually in 4 yards. This is in 3 yards from the year before, and this is in 4 yards. And we were able to show that. So again, now you can look at that time of year, okay, what am I going to do, to prevent them from reinfesting? We don't have a lot of solutions on that right now, but you can use that information to go there. Okay, so this is again status of adult reinfestation. We actually just this is more visual. We didn't see a lot of difference between colony strength and that, but looking in, like you think they'd attack weaker colonies, but we seem to see a lot more adults in strong colonies. There didn't seem to be a big relation as far like relating to colony health and adults. It almost seemed the stronger they are and healthier, the more beetles would go in. But the fact is, if you have a colony going downhill, you just need a few, like that amount of adults is really, it's not relevant until you have a colony going downhill, like queenless, and then they're just going to jump on that colony and take it over. You can have a strong colony and thousands of beetles, but they'll never be able to take advantage of that. If you have a colony going down, you just need a few beetles, and they'll lay thousands of eggs. We also noticed, and I think this is really relative to quarantine zone and the success that we've had in Paul's and the inspectors have put into maintaining that the beetle they really do move with bees. I mean, they can fly really far and all that, and you have these kind of odd ones going here and there, but the mass movement is really with bees. And even within yards, like we could see, related to the amount of larvae produced in that yard, the reinfestation rates would be higher in that yard. So it's really seemed like the beetles, as long as they have the place to stay, they'll go back into those colonies. So if you don't move the colonies around, like they'll just kind of stay with them more than move out. I'm sure if there's these population dynamics, if they get huge populations, not enough bees, they'll start taking off. But really the mass migration is with bees. And so there's a lot you can do within your own yards if you're able to control them, have good hygiene. If you don't clean out a barrel or you leave a dead out, that yard specifically is going to be more affected than another yard. So you can do a lot in a yard to control small hive beetle. So this is a example of a dead out. So this is the peak of larva production that we see at the end of the year. Most colonies don't produce larvae in September, but if you're not looking in your yards and looking for dead outs or for laying workers, this is a laying worker colony. You just kind of let them go to the end of the year and take the dead ones out before you overwinter or something. The few that are left are going to produce huge amounts of larvae, the laying workers. So you could have a yard of 30, 29 are strong, no larva production. You have one that went laying worker, and this is what you can see. So this is the bottom board of that same colony. So just mounds of small hive beetle larvae. I always mean to put a soundtrack to this, some horror kind of music and that. It's kind of nasty. Yeah. So I think it's just a good example of how one colony can get out of control. Some other kind of music needs to go on for that one. What's going on there, but. So this was, we found this colony, and we knew there was more larvae coming to this one more than other ones in particular. And actually Mel dug into it further. Again, one of those things you just try to get through your work, and you need someone that takes the time to really investigate further, and she did that. So she found this. So this is what it looked like. We put the colony back together. We came back a week later. We took some samples of that first, and I'd like to show. I don't know a lot of you have seen this. These are the larvae in alcohol. And usually you put an insect or a sample in alcohol, they die fairly quick. These guys, they do that for about an hour. They keep on going. Yeah, it's a party in there. So what we think with that, there could be a market if we could come up with a local alcohol and put small hive beetle in the bottom. And you know, you got to look for opportunities in these situations, right? Okay, so we looked at this colony a week later in these traps. I don't know if you remember the tray I showed you at the start. There's a few larvae. This is that colony the week later. So it was overflowing with larvae coming out of it. Just one colony. So the difference between the spring, where you have a lot of colonies producing a little bit of larvae coming out, in the fall you almost have no larva reproduction except for the couple problem colonies that produce a huge amount. And you don't look in, you don't really see a lot of adults, but you just need a couple of them. They lay thousands of eggs. But the cycle, they all came out at once and they were gone. There really weren't any larvae left in the colony. They just all flushed out in one. So there's something in there that we don't know about, like that signals the beetle to take advantage, lay a whole bunch, and then stop. Because there's still resources to keep going, but for some reason that cycle, it's just, okay, now's our time, and then that's it. So this is, we had to count all this stuff when we collect it. So we get it on the plate. So I usually get people asked, but I know some people know the answer. In 1 week, 4,000 larvae came out of that colony. Yeah. So it looks good. So, you know, fry that up, have your liquor with the worm in the bottle, fry this up, probably have an accompanying dish. You got a local meal right there. Yeah. Yeah. It won't be long till we'll want to promote small hive beetle growth. So this just emphasizes like good yard management, you know, making sure you're getting rid of those problem colonies, because you just need a couple to cause a big problem. So we did check out some of these traps. So we looked at, we did that in collaboration with Piero Giovinazzo and a master's student, Martine, that he had working for him. And we're looking at, these are traps that you'll see on the market for catching adults inside the colony. So this is the AJ, this is the beetle eater. This is the hood trap, and this is the beetle barn. And the beetle barn actually has a little piece of checkmite that goes inside. The idea is that the beetle, this folds in half, the beetle comes inside, touches the checkmite, and dies. So we checked these traps, and we were able to show that the AJ beetle eater caught more than the hood trap, and the beetle barn really did nothing. And we think it's actually probably more of a risk than anything, because you have beetles touching checkmite, going down to your colony, contaminating your equipment. And I'll talk a little bit more, but we all know the risks of checkmite and coumaphos, right? So we really wouldn't encourage that. But really, the fact is that the amount of beetles that you're trapping it's not a control. You know, you can go in, put them in to see if you look and you can find them. But again, if you have a weak colony, if you have a strong colony, beetles won't be able to take advantage of it anyways. If you have a weak one, you just need a few left, and they're just going to go berserk. So the amount that these ones would trap, you can't really consider it a control. But you could use it as a monitoring tool. Okay, so a lot of the new work that we did last year was with Permanone. So this is a recommendation that came out. It came from really from the U.S. So Permanone, which is permethrin, it's a soil treatment. So the idea here is when the larva is in the soil, you treat the soil with Permanone, and it will kill the larva or the adult pupa or whatever's kind of in there with small hive beetle. So that product and the recommendation to use that came out of the U.S. It's very toxic to honeybees, this pesticide, so there's a lot of care that needs to be taken when you're using it. You really need to make sure you have good contact with the ground. So if you have high grass and you're applying it, it just sits on top of the leaves and the bees get onto it, that's a risk to them. You want to prevent pooling, so flooded areas where it can sit in water and that kind of thing is a risk. Using the right dosage, and that's actually, when we got into actually testing this, we started to realize there weren't really a lot of defined recommendations on application. So how much per colony or how much per area, just said mix it at this rate and apply in a yard. So that was the challenge for us. Okay, we're going to set up an experiment. How much do we actually use? So the best we could do with all the information we gathered to get what would be a normal dose we would expect someone to use was a liter per colony. And this was actually applied in front. So we had a frame. And we applied it, before I go there, we applied it at night. And the idea here is that, if you do it in the daytime, you have all the water and that application on top and the soil, and the bees are more likely to come into contact. So we did it in the evening, so it had time to soak into the soil and be less of a risk to the honeybees. So we prepared the ground. We cut the grass to make sure we had as much contact with the soil as possible. Mix the solution. And there's a lot of protective gear that goes along with this, because it is toxic to, it's not really a safe chemical to humans either. So we had masked. That might have been a little overkill because we're really just drizzling it on. It's not a mist spray, but the recommendations say you should have a mask, definitely gloves, and coveralls and boots, so you're not getting it soaked onto your skin. So we made these frames to control our application in front of the colonies. So we had it 50 meters in front of the entrance and 50 centimeters and 45 centimeters out. And that was the information we could gather was the recommended area in front. So the larva would come out in here and come in contact or go in that soil and have a kill. And we did that in front of all the colonies. We had 4 yards. We had 2 yards where every colony had this application in front of it, and 4 yards that had no application. And that's the way we were able to have 2 controls and 2 treated. You couldn't have controls within a yard because, if you apply one here, you don't apply one there. Well, you don't know if the larva that you didn't treat there would come back together. So we just had more yards treated and more untreated as control. So we treated, then what we did was we monitored. We had dead bee traps on to see if we could show any effect on honeybees. So actually, if you use this, that you're going to actually harm your bees. And we had our teal traps to measure larva production and reinfestation rate. So when we applied this, we were able to show, with those cycles we identified, knowing right when most of the larvae would be in the soil, we applied it in order to capture the largest population of larvae and the largest amount of the population of small hive beetle in the soil as we could at a point in time when we knew it was there. Using our mentality of how IPM works, you monitor and you apply at a certain time and to get the best results you would predict in your hypothesis. So that's what we did for measuring. We didn't find any effect on honeybee health. We were really careful in how we applied it, so we were happy to see that. Mostly because we didn't want to kill Tom and Roger's bees in our experiments, but it didn't. We didn't see any effect on bee mortality, but we also didn't see any effect on small hive beetle mortality either. These are the reinfestation rates. These are adults coming in those 4 yards, and this is larva. But so what I wanted to show here is it's kind of hard to match some of these lines, but basically, so this is a control yard, this is a treated yard, and there's a control and a treated down here. So the variability was the same in each. We did run all the stats on this, and Brian did a good job of it, and we weren't able to show any significant effect on reinfestation levels in a treated or untreated yard. So we're recommending, in a 1-year study, we're recommending a product, and I should give some background. Permano's never been actually, there were no trials field trials done using Permanone to treat for small hive beetle. And I found this out more with when I was speaking in Mexico, and there was a speaker there that was in the West Coast lab that worked with the chemist that actually she just in the lab tried Permanone to see if it would kill small hive beetle, and it did, and so that's where the recommendation comes from. It was never actually tested in the field, so we did that with the knowledge that we were able to gather, and we actually saw no effect. So that really calls into question why it's really in our recommendations to use it, a chemical that is fairly toxic, and then all the issues that come along with it, right? Like our bees are on other people's property. You know, should we be putting a soil treatment into land that's not our own? You know, there's all those other concerns that come along with it. And the fact what we were able to show, it really didn't work at all. Even if we saw some effect, some, you know, insignificant, but some effect, you know, like we said, if you don't have healthy colonies, it doesn't matter anyways. You need to kill like all of them, basically, for it to make it worthwhile. And there wasn't any significant effect. So I think, you know, it's a negative result, but a good result nonetheless. And working with Paul is great when we work on the treatment recommendations, how we can work that in and say, you know, it was in there, but after doing some work on it, you know, maybe it's not such a good idea that you try using this treatment. So this works into, again, integrated pest management. So we did a lot of work to understand the development of small hive beetle, how to monitor for it, when you can find it, when larva production is, when adult reinfestation happens. Economic thresholds, that's a big question mark. We don't really know much about small hive beetle there at all to really decide whether to treat or not. But your treatment options, there's only 2 of them, and one is, so I'll talk about that in a second. And then actually observing the effectiveness of the treatment. So we did the small hive beetle development. We were able to repeat it 2 years in a row. Monitoring, you know, those traps, like I said, they're not really a control like they claim to be, but you can stick them in there to look for the beetle, and it's a good way to monitor to see if you have it, and then see if you need to start taking some measures to stop the amount of reproduction. You know, you might put more focus on hygiene in your yards and that kind of thing. But this was, I think, I know it's not in commercial development, but we have an approach now by someone who's interested in making these for sale for a reasonable price. But this was a great trap. But you know, you do have to put it on in front of your colony. But even if you put it on a few colonies in a yard, you can get some good results for monitoring. So yeah, economic thresholds, it really depends on your colony health. Like if you keep healthy colonies, that's the same thing. But queen in the fall, the queen status really seemed to be the big one. You can even have a weaker colony, but still with a queen, and the larva wouldn't reproduce. But as soon as it goes queenless, becomes a laying worker, they just kind of seem to go crazy. So the treatment options, check mite, that's one that's out there. You know, we haven't really been able to show it's effective either. We have all kinds of contamination issues in the colony and problems with resistance. So we wouldn't really recommend that. And of course, Permanone, which I just explained, wouldn't really be an effective treatment option. So the best management practices that we've came up with, kind of a good general one, and they'll be in the treatment recommendations too with Paul. You know, good spring cleanup and maintaining good apiary hygiene. Moderate pollen supplementation in the spring when larva is reproducing, so you're not giving it a place and promoting its reproduction. Maintain healthy colonies, especially your queen status. Remove, or correct compromised colonies in late August and early September if they can produce a huge amount of larvae. And quarantine really does seem to be effective. You know, I think we've been pretty successful there compared to the U.S. where there's none of that ever happened. It just went everywhere really fast. In Mexico, they're actually quarantining areas with small hive beetle, and they haven't seen it spread, and there's some really ideal places for it to be. but it doesn't seem to move unless you start moving colonies around to a large extent. So I just want to thank the OBA. Well, a lot of our funding came from AMAFRA that gave the OBA a good amount of money, and the board, they were generous to give us a good chunk of that to do this work. So we'd like to thank the OBA for supporting the tech transfer program to do the work and get in the field and come up with a lot of this stuff. It's been a great experience, and in the Congdons as well, for letting us work and with their colonies. We wouldn't have been able to do it without them either. So that's kind of a summary. You probably won't hear much about small hive beetle from us for a while unless something else comes up. We might do some stuff with honey house issues. We haven't seen a big issue in honey houses yet, but we might have a small project with that. But we are kind of wrapping up the funds that we have for that. There's so many other big priorities. It's kind of hard for us to justify really applying for a lot more money to work on small hive beetle, especially with what we found. So any questions you have, you can always call us up too. But if you have any questions for the moment.
That's fabulous work. With respect to your trends, would you say that in the US, those who really know and have experienced it, would they have experienced a similar trend?
Maybe comparable, at least to northern, where they experienced the same winter. Like what we're wondering, like if maybe our winter kind of is like a reset button too, like they can't reproduce until spring hits. And then it starts that cycle, so it's kind of really evident. But maybe an environment where it could kind of get off sync, maybe you wouldn't see that. We don't really know. But it could be there. We don't know anyone that's ever looked at it. Yeah.
Les, have you done do you have any recommendations as far as when we go to a hive in the spring and it's dead or it's drone layer or whatever, we clean it all up in the yard. Is it a good idea to take that potential colony back to our honey house and shove it someplace temporarily? Or what do we do with those deadouts when we can't do something with them?
And well, if you have small hive beetle,
assuming
yeah,
small hive beetle.
Yeah. So freezing them would be ideal. Like you can't freeze to kill them out that way. That would be the best recommendation before you stick them in. Yeah, with stored material where you can start to get into everything, then you could have a lot more problems in your storage areas in your honey house.
Second question to that, I guess in the fall, if we come across a drone laying colony and it's in contaminated, full of larvae, 4,000 beetles, what do you recommend we do in the bee yard when we find that? Is it dump them out and jump up and down on them, or take
no, that's a good point. I'd have a good soapy bucket to throw it in and drown them and get them, even freeze them. I don't know if soapy water would kill them or how long it would take, but you definitely want to contain. You wouldn't want to throw them on the ground and get them into the soil. Yeah.
In Saskatchewan or Manitoba, where we're looking to monitor to see if we could potentially be getting it, we've been using those commercial traps. How effective do you think those are relative to your teal trap? Do you think we'd be better off to invest in building or making the teal trap and use those for monitoring instead? Because the ones you had caught like next to no mites or next to no beetles compared to the other traps, right?
Well, the commercial ones that go inside, they're kind of nice because you can just kind of put them in and leave them there. The ones that go on the front, you do have to be dedicated to really coming back and maintaining them a bit. I think you get a lot better results with the teal traps. The convenience of the other ones are cheap, and you can stick them in and kind of forget about them and come back. If the beetles go in and die, they're going to stay in there, and that too. So there's kind of both those two aspects. For research and really thorough monitoring, and for like research, the teal trap was by far a better tool. The west trap? No, I'm getting the name wrong now. Trap that goes underneath, west trap. Paul used that a fair bit, and it worked pretty well as a commercial trap. I think we didn't test that one because it wasn't part of our project. But you do have to stick that. There's a little more work to get it out under the bottom board and that kind of stuff. And Paul has another one he can talk to you about later too, where he's actually shaking them into a bucket through a screen as a one-time hit kind of look. So that's more if you're in the yard and you want to look, then you can use that one. But these traps, you can put them on and leave them and come back later.
Okay, kind of in the same thing. Do you think those commercial traps because potentially we'd have small hive beetle in really low levels. You think they'd be effective enough that we'd pick up low-level infections?
They might not, actually. Yeah. The really low-level infections, Paul's method seems to have worked really well with shaking out large amounts of bees through a screen. For the front trap is really mostly effective when you see reproduction larvae coming out and them coming back in. If they're kind of at a stage where nothing's going out or in, then you might not see anything with the teal trap. Okay. One more?
All the treatments that I've heard so far have been relying on chemical. I wonder if there's any potential for biological controls, which they have, say, for loose drive beetle and that sort of thing.
I haven't heard of one that's effective. But probably by far your best control is a healthy colony. That's really what it comes down to. A healthy colony is your best control because you can't eradicate them. You only need one or two living in there. Because any treatment, there's no real treatment, no matter what pest, that eradicates everything. So as long as you have a really healthy colony, that's your best control.